Well, as maybe you can tell from the bio, my strong point is not alfalfa. My strong point is grass production, grass hay production, native rangeland type of scenarios. But when you're the state range or the state forage specialist, you kind of get stuck with doing all of the above. And so Holly called and wanted someone to speak on, first there was maybe a couple of different topics, and finally got her to give Anwar from Wyoming one of those topics. But I ended up with this one on digestibility and forage quality, and in particular wanted to talk about these new low lignin alfalfa varieties. There's not a whole lot out there yet. There's a lot of hype, but there's not a whole lot of, especially research data available. And they asked me to talk for a whole hour. It's like, I'm not sure what I'm going to talk about for a whole hour. So today what I'd like to start with, and I'd like to give Dr. Dan Undersander from the University of Wisconsin credit, because he was willing to share his presentation that he's given in a couple of these other programs, Alfalfa U programs. And I took his presentation and kind of added my touch to it, but I used a lot of his data and a lot of his diagrams and things that I'll be showing, going through today. So first I just want to give you a little background information. Just what is this whole idea of digestibility, forage digestibility? Why is that important? So basically when we talk about digestibility, it's just the proportion of the dry matter that an animal intakes, and what proportion of that is digested and provides nutrients and energy to that animal as it goes through the digestive tract. And so we use digestibility a lot as an indicator of the overall energy content of that forage, as well as the ability to supply the other nutrients that the animal needs and meet its requirements. So typically we think about the higher the digestibility, the more energy content that forage is going to produce, and so the better gains, the better milk production that you can expect out of that particular forage. The other thing we have to think about when we're dealing with these ruminants, whether you're dealing with a dairy cow or a feedlot steer that's we're trying to put some gain on, it's that rumen is that kind of the bottleneck in that whole digestive system. And so we want that forage, that high fiber forage, to pass out of that rumen as quickly as possible. So the quicker it digests, the quicker it passes out of that rumen, again, the higher the intake's going to be, so the higher the milk production, the higher the gain that we can expect off of that. So what factor do you think has the greatest impact on forage digestibility? Talk about growing these forages, whether it's alfalfa, grasses, it doesn't really matter. What's the one factor that has the greatest impact?
Maturity?
Maturity. Far and away, when we talk about the impact on forage quality, it's going to be maturity stage of that particular forage in which it's harvested, grazed, or whatever it might be. This is one of my favorite diagrams. I use this quite a bit in my coursework that I teach at CSU, because to me this really kind of puts the whole picture together in my mind, and why we harvest at certain times. And this in particular is a diagram specific to alfalfa, but you can apply this to grass or whatever type of forage you're dealing with. So it's, as we go from this late vegetative, where some guys might be cutting to try to get that high quality, dairy quality alfalfa, and we go from there to this late bloom stage, you're going to see a decrease in our free protein content. We see a decrease in that digestibility of that forage. Then we see this increase in this cell wall. What's the importance of this cell wall? How does that impact our overall quality? You see it's increasing. Is that a good thing or a bad thing?
Increase the fiber?
It's a bad thing, right? It's an increase in that fiber. We're going to talk about all the different things that make up that cell wall here in just a few minutes, okay? And then bring that back to this whole idea of trying to lower that lignin in these forages. The other thing, again, it's talked about in the previous session about this yield quality trade-off. That's always a big issue. So in this alfalfa example, early on here until we start to get into that bloom stage, we have a fairly constant rate of increase in our yield component. And once that plant goes into starting to bloom, then that rate of increase, it puts more energy into putting that bloom on those flowers and producing that seed. So the rate of increase, the rate of accumulation of that dry matter begins to slow down. And this was kind of, when I finally kind of understood this whole diagram, everything kind of came into good focus for me. So when we look at, this increase and it slows down, and then we look at this kind of this darker shaded area down here, and that's the yield of digestible dry matter. How do we figure that? How do you figure the yield of digestible dry matter on a pounds per acre basis? Well, two things on that graph are we multiplying together. So you got your total yield, right? Total dry matter yield, and what do you multiply that by? You get yield by digestible nutrients. You like my class, Becky? Everybody's quiet. By the digestibility, right? The percent digestibility. What percent of that, that goes through the digestive tract is actually digested? Okay? So you multiply those two together, then what happens? You start to reach this plateau, right? And if you let it go clear out here to full bloom, and you get that higher concentration of this cell wall component, we actually start to lose more total yield, but less yield of digestible nutrients. Okay? So why do we typically harvest alfalfa at that late bud, early bloom stage, at 10th bloom? Because that's where this plateau occurs, right? Where you get the highest yield of digestible nutrients. So what's this equal here from this yield of digestible nutrients up here? What's that factor? I call that the poop factor. That's the manure factor, right? Because this is indigestible materials coming out the back end of an animal if you're feeding it that very mature type of a forage. So again, we try to come back here, we're going to give up some total yield, but we're going to maximize our yield of digestible nutrients. All right, so I thought maybe we'd go through some basic information here, kind of basic how a plant is put together, okay? So here's just a diagram that represents an individual cell in an alfalfa plant. So in the center part of that cell, we have these cell solubles. This is the goody part, right? This is sugar, starch, fats, protein, high percent of the proteins found in there, pectins. So this is highly digestible, very highly digestible. Going through the rumen, this is where you're going to extract a lot of energy. 90 to 100% of those cell solubles are digestible. Okay? Then the issue comes in is when we start to talk about this cell wall. We're going to talk about each of these three fractions here. Hemi cellulose, cellulose, and the lignin make up that structural component of the plant. And when we talk about this, that cell wall, only about 30 to 60% of that is digestible. It's highly variable. In a younger or immature plant, can have higher digestibility. As that plant again goes to those later stages of growth, you're going to see the digestibility of that cell wall fraction become less and less, approaching that 30%. So if we go just, just with a simple diagram of a cell, you have all these cell contents in here. You got the chloroplasts and the mitochondria and proteins and all the genes and everything's all jumbled up in there. And that's a highly digestible fraction. And early on in the growth, you're going to have these developing cells and developing cell walls. At this point in time, again, these are fairly digestible. And then as you go on later on into maturity, as that plant gets taller, I always think about it as you're building a house. Okay? The framing of the house, the walls, the studs in your house are what holds the house up, right? That's what that cell wall does to the plant, is it holds it up, gives it the structure. The taller that plant gets, the more stronger that structure has to be. So here we have, primarily two major components are the hemicellulose and the cellulose, and some pectin and some proteins and other things combined in there in that developing cell wall. And as we, again, get a little bit later in maturity, we have an actual secondary cell wall that develops on the inside of that primary cell wall. So here's the primary one, that's fairly thin. This is that big, thicker part of the cell wall. It's going to give that plant the structure. So here we have the hemicellulose. We have some lignins going to be laid down in there, as well as the cellulose. So it's going to go through each one of these. So the pectin. Does everybody know what pectin is? What do we use pectin for? Jellies, right? It's what causes it to firm up, right? The polymer of these sugar-type acids, mainly composed of this pectinic acid. It's a water-soluble type of a compound. It's able to form these gels in the presence of acids and sugars. We mix a lot of sugar with our jelly, and a little bit of pectin causes it to firm up, right? It's a major component of this middle lamella, which is kind of the right between each of these cell walls, okay? So basically this pectin helps to bind those cell walls to one another. To me, I like to think of it as kind of the glue that holds the cell walls, each of these individual cell walls together in the plant. We have the cellulose, made up of glucose units, just basic sugar units. It's a straight chain type polymer. Starch, which is a storage carbohydrate in alfalfa, one of our forage type plants, is also a chain polymer of glucose. But the polymer in the cellulose is non-coiling, non-branching like it is in the starch. The starch, it has to be able, the plant has to be able to draw upon that to meet its energy needs when it's not, being able to satisfy all of its energy needs through photosynthesis. So, to me, I like to think of cellulose. Here's an example of actual cellulose fibers. It's basically kind of like a rope-like structure. And if you think about the way a rope is put together, there's many small fibers that are wound together, right? That end up forming the actual rope. And that's the same way as a cellulose fiber is put together. Many small strands of these glucose polymers end up being wound together to form these rod-like type structures. Now, it has some stiffness to it, just like depends on what a piece of rope is made out of. Some of it is very flexible and pliable. If it's made out of something that's a little stiffer, then that would be something that would equate to an actual cellulose fiber. So a lot of tensile strength, but it's got some flexibility to it. Okay? It's going to need some other things to it, going to help make that plant stiffer and be able to stand up over time. So here are these black strands running through here, what represents the cellulose fibers. Hemicellulose, it's a complex, made up of complex sugars. Glucose would be one of those, but other things like this xylose, mannose, galactose, ribose, ramos, all of those different types of sugars. The cellulose is highly ordered, and but cellulose also has areas where it's less ordered, and that's where the enzymes, say that are that are produced in the rumen, can actually attach to that cellulose fiber and actually degrade it as these areas that are a little more amorphous or branched, especially this hemicellulose. So hemicellulose is a lot more digestible compared to the cellulose fibers, I guess is what I'm trying to say here. Easily hydrolyzed in dilute acids and bases, as well as with the hemicellulose enzyme. So it's represented here by these kind of light blue strands running through here. It can have some branching associated with it. It's not just a simple straight chained molecule. Then the big one here, the lignin, polymer of aromatic type alcohols. Cellulose is the most abundant organic compound on Earth. Lignin is going to be your second most abundant organic compound on Earth. Constitutes up to about 30% of non-fossil organic carbon that we find. I guess one of the things I wanted to point out here is, to me, this is kind of a cool thing. It's one of the most slowly decomposing. When you think about the plant, it's part of the plant that decomposes the slowest. So this is what's really going to add to your organic matter, basically the humus that we like to see in our soils. And then that humus, really adds to both the water holding capacity as well as the nutrient holding capacity in our soil. So then we have these lignin molecules that are kind of intertwined between the hemicellulose and the cellulose molecules, and then that's going to help to eventually bind everything together and give that plant its structure. So fills the spaces between the cellulose, in the cell wall between the hemicellulose and cellulose, as well as the pectin in there, and it's going to actually eventually link or bond to the hemicellulose molecules in the plant. And that's really what's going to start to provide that strength to the plant. And so allows the plant, to transport water up and down through the plant, maintains that xylem and phloem in the plant that transports the water and the nutrients up and down. Didn't have that, that give that plant that strength and maintain that tubing structure within the plant would just wilt and not be able to grow and stand up. So this lignin is going to increase again, as I said, with increased maturity. And then when you think about lignin, it's a woody type material, basically. It's what it represents. We find in a lot of our trees and shrubs and those types of plants. It's basically indigestible, 100% indigestible. And then when it links with that Hemi Cellulose and basically surrounds some of those cellulose molecules, so it's totally indigestible, but as it increases and bonds with that Hemi Cellulose, it makes both the Hemi Cellulose and the cellulose molecules less digestible. So again, that's why we see that digestibility of the cell wall go down, let's say that 60%, down closer to 30% as that plant matures. So these plant lignins, there's 3 basic classes of those. There are softwoods like your pines, your evergreen type plants, your gymnosperms are composed principally of this coniferal alcohol down here in the corner. Then we have the hardwoods, our deciduous type trees, your angiosperms. Those are composed of the coniferal plus the cynical type alcohols. Then your grasses, annual type plants, graminoid type species is comprised primarily of that coumaral alcohol there in the middle. So when we think of alfalfa, the principal type of lignin that it has is this coniferal, like those softwoods, like your pine trees have. It's a very similar type of a lignin as the pine trees would have. So when this whole idea of the low lignin varieties and the companies that are working on this, there's 2 different approaches that have been taken. Alpharex has taken a non-GMO approach and has developed some low lignin varieties through traditional breeding practices. And then there's this group that includes the Noble Foundation out of Oklahoma in conjunction with Forage Genetics and the Forage Dairy Research Lab out of Wisconsin. We looked at a GMO approach, and basically what they're trying to do is silence the gene in alfalfa that produces some of that lignin. Okay? You can't get rid of all of the lignin. You can get rid of some of it, still have that plant stand up out there in the field without lodging, and try to increase the digestibility, intake, beta passage, energy content of these alfalfa plants. So they've taken 2 different approaches. They've silenced this one here. Most of the literature will abbreviate that as a CCOMT enzyme that produces G-lignin, and then this COMT enzyme that ends up producing this S-lignin in the plant. Alfalfa contains, the largest part of it is composed of this G-lignin type in the plant. That does not mean that that's the one that you may want to silence, okay? Again, because you have to maintain some lignin in your plant for that structural component. So there's different ways, it was talked about in the other session there, you have this new low lignins coming on the scene. How well are the techniques, laboratory techniques, going to be at measuring this in the plant? Lignin in and of itself is a very difficult part of the plant to measure. I mean, it's not soluble in water. It's pretty much resistant to breakdown with even strong acids. And so it's a very difficult part of the plant to measure and get a good measure, accurate measure of. There's different wet chemistry methods. You can use this potassium permanganate. Probably the more common one is the second one there, the use of sulfuric acid. And this is straight concentrated sulfuric acid. You basically take a known amount of the ground up forage and you let it soak in this concentrated sulfuric acid for about an hour or so. And it's going to dissolve, solubilize the cellulose and the hemicellulose in the plant. And basically then you measure what's left. And what's left is assumed to be the lignin component. Okay? This will be on some of your forage test reports. This will be known as the acid detergent lignin component. You might see that on some of the reports. Then we can also use the NIR method, just non-destructive, and then reference that back to the wet chemistry. According to some of the reports that I've heard, this method has been showing maybe a little bit of variability. You probably need to get some of this wet chemistry done on these low lignin varieties and get these numbers added back into some of these equations in these NIR machines, and hopefully we'll take care of some of that variability. So we're getting good measures when we send a sample to the lab.
Hey, Joe?
Yeah.
Is there, does climatic conditions or environmental conditions affect lignin?
Yeah, definitely. Climatic conditions, typically hotter, drier, it's going to lead to higher lignin concentrations. Cooler, moisture type conditions will have less lignin laid down. So that's why your first cutting alfalfa a lot of times is lower in lignin than say your second, third cuttings that are taken during that hotter part of the growing season. Even though you have maybe less stem, actual stem, the stems are smaller in that second and third cutting. So cooler will typically lead to less lignin. Now the big issue when we talk about alfalfa, compared to some of the other forages, is alfalfa contains upwards of around 7% lignin. You look at some of our grasses, typically 3 to 4% lignin. Here's some corn silage samples here, around 3%. So it has almost twice as much lignin or more than some of these other forages that we deal with. So this is just some from the National Forage Testing Program. They send these check samples to these different labs, and the labs run them. Again, it's talked about how you can send a given sample to one lab and you send it to another lab and you get totally different results sometimes. Again, this is that variability that you see. The average of about 20 different labs is right around 6.7, but the minimum was 4.9, clear up to 9.2% lignin. Grass, 2.8 up to 6.1, corn silage from 1.6 to 7.8. Again, no matter which one you're dealing with, there's quite a bit of variability between the labs. Again, there hasn't been a whole lot of research done yet. I think people are just really gearing up to do a lot more in this next year or so. Dan Undercenter and his group out of Wisconsin, Dan Putnam and the group out of UC Davis there in California, and Craig Schiefer out of Minnesota there. I've done a little bit of work with some of the early accessions, I guess, of some of these low lignin varieties. So they did a little study, 5 different locations. So they have this Legend 5.0 is kind of their check variety here, which is illustrated with this top line here. So it's a little more productive. This is the yield from those 5 locations. And then you have the one where this COMT variety with the null means it is still active, has the active, is producing lignin. And then you have the one where they've inactivated that. Again, both of those different pathways in the alfalfa. Again, as far as yield, this is going from late vegetative, and then they harvested it every 5 days. So by the time you get out here, you're probably full bloom, almost seed set type of growth out here. Not a whole lot of difference in the actual yield of those different varieties, whether you have the lignin turned on or lignin inactivated. So, some people have been concerned there might be some yield drag or some yield differences when we inactivate that lignin, but according to these preliminary data, it doesn't seem to be the case. Here's the big kicker that we want to see, when you reduce that lignin. So these are the 2 different pathways where the lignin has been at least partially suppressed. This is the neutral detergent fiber digestibility, EDF digestibility. So the higher that number is, again, the faster that's going to pass through the animal, the higher the intake, higher the energy value in that particular forage. So again, both of these 2 very similar types of digestibilities compared to the ones where the gene is still active, or to that Legend 5.0 check variety. Very similar digestibility. This is a study that was done, again, with some early feeding trial with some lambs. We had 100% alfalfa hay, again, those 2 different gene pathways, the active versus the inactive. As far as total NDF, the total cell wall fraction, not a whole lot of difference, whether it was active or inactive. Did just seem to be, in both situations, slightly less total lignin in the plant. What was significant on this one, again, the NDF digestibility was significantly higher, inactivated that pathway, and then that led to higher total digestible dry matter. The trend was the same, but not quite as, wasn't significant statistically, but similar trend, with higher NDF digestibility and a little bit higher overall total dry matter digestibility as well, with a slight decrease in total lignin in the plant. This is one where they, some lactating dairy cows, being the same two types of alfalfa, active and inactive. Crude protein, very little difference. NDF, there was some differences in total NDF. And the inactivated, the lignin gene, again, not really significant, no, statistically not significant. Again, this one here, higher NDF digestibility. And then when you translate that to milk production, about a 2.6 pound per cow per day increase in milk production due to that lower digestibility, or higher digestibility, including that low lignin variety in the TMR ration. Again, there's always been this big trade-off between yield and quality. You always try to sacrifice some yield to get some higher quality, and especially when we're trying to get some of this dairy quality type alfalfa. You can really sacrifice a lot of yield sometimes to do that. So here we have the yield curve and the forage quality curve. And then we throw on top of that these lower lignin varieties that should have the higher digestibility, kind of decrease in quality at a slower rate. So we can kind of push that on out to a later stage of growth. Then when we start looking at this, we can, if you take the same quality, we can reduce or extend out, I guess, the harvest window, sometimes 5, 7, some people are saying maybe up to 10 days, and still maintain the same quality. That's what that line there is showing. But then we can increase that overall total yield. We're pushing that out to a later stage of maturity. We're going to capture more total yield of the plant. So higher quality, higher yield, or same quality, higher yield in that scenario, I guess. So this whole idea, and I think this is where maybe low lignin and alfalfa's varieties can really maybe shine a little bit. This is some data, some old data that Dan Undersider had from just some conventional varieties, looking at 3-cut versus a 4-cut system, and the impact that had on total seasonal yield. So this, in the second year of production, you see here with the 3-cut system, over the total season, they increased total seasonal yield by about 17%. In the third year, about 25%. Total yields were down a little bit compared to the second year, but on a percentage basis, they increased the total seasonal yield by about 25%. So again, I think, depending on how you can adjust your cutting schedules, this might be one of the main benefits, or a big benefit anyway, of going to some of these lower lignin varieties, is maybe taking one of those cuttings out of the system. So again, Alpharex has taken the non-GMO approach to the traditional breeding. Their percent lignin reduction is an average of around 7 to 10%. Forage Genetics, somewhere in the 10 to 15%. Some numbers as high as 20%. Looks like maybe 12 to 15 is where that's going to fall out in the end. This is the percent unit reduction, so half to 0.7 of a percentage point reduction there with Alpharex, and then 0.7, a little over 1 percentage unit reduction there. If you assume that alfalfa has about a 7% total lignin content. So right now, Alpharex has two varieties, I think, that are on the market. This High-Gest 360 and 660 varieties. They were released in, I think, 2015. It's the first year they were planted. The 360 has the fall dormant 3, and the 660 is the semi-dormant fall dormant 6. So, like Brian England, in Aurora, they should be able to use this, get this cleared, be able to use this in organic production. Whereas with the Forage Genetics, the GMOs, they're not be able to use that one. I guess a potential advantage here is we've got going to be additional tech fees like there are with the GMOs. I think additional seed should be available. I think, and Tom, some of these guys can comment on this, but I think a lot of that's already been spoken for. It's been already some of the stuff I found online, as far as some of the dealers out there running in $670 a pound, is what I saw online. I'm not sure where all that's going to settle out in the end. One thing that I found kind of interesting, I haven't seen any of this growing in the field, but it's been reported that some of these from Alpharex have these denser leaf canopies, denser canopies, and more leaves that go lower into the canopy on the plant. So that could be a positive thing too. Because leaf is where your quality's at. The Forage Genetics, they just got this cleared, and I think there'll be limited seed available in 2016 here. Again, this is the knockout gene, the silencing of the lignin enzymes. They're going to call this hard extra technology, so just like the Roundup Ready. This isn't going to be the name of the variety, this is the name of the technology. So there'll be a variety name associated with these different technologies. Again, I'm sure eventually there'll be a number of different fall dormancies that contain this technology, just like the Roundup Ready gene. My understanding is it's going to be stacked with the Roundup Ready gene as well. You're not going to be able to buy them separately. They're going to be together. So I think there's going to be a tech fee associated with both traits. We already kind of know what the Roundup Ready tech fee is. Wasn't able to find anything as far as what the hard extra technology is going to be.
Joe, I've heard that that will sell for approximately $12, $13 a pound.
Well, you add both tech fees on there, and if the tech fee is fairly similar to the Roundup Ready, it's probably going to be pretty expensive. So, kind of sum this all up, what's the value of this reduced lignin? Definitely improved forage quality, higher digestibility of that NDF fraction, and reduce the lignin. Reduce the lignin, there's less lignin that's going to interfere with the digestion of the cellulose from the Hemi Cellulose. It's been reported that we can increase both the rate of digestion as well as the extent of the total amount of digestion of that NDF fraction. And it's going to relieve that. Less gut feel, higher rates of passage, higher rates of intake, higher amounts of energy the animal is going to be able to extract from that forage. Should result approximately about a 2.5 pound, if you have a dairy cow, 2.5 pounds of extra milk per cow per day. And then if you're going into a feedlot ration, it should result in higher rates of gain there as well. The big issue is, a lot of this has been done, there's that one study, but most of this has just been done by running it through some of the milk programs, and we really need to get some additional feeding trials out there to see exactly how this is going to feed, and is it going to actually end up with these kinds of increases in the end. Wider harvest window, greater flexibility. We were talking about the issues with rain, and do you cut, do you not cut? If you continue to harvest at, say, the normal interval, your 28-day interval, you should be able to capture higher forage quality, because you're going to have higher digestibility of the NDF fraction. And so instead of having to maybe go to a late vegetative, early bud stage, you can go to a little bit later stage of growth and still capture a premium type of dairy quality alfalfa hay. You get that premium for that when you sell it. Or you can go to, say, a later harvest date, push that out 7 days is what a lot of people are using, maybe up to 10 days with some of the Forage Genetics having a little higher reduction in the total lignin. So again, get that greater yield per cutting, the same quality as you get at that 28-day cutting. Again, that potential to reduce the total number of cuttings per year. think that there's a lot of the potential advantages. I know around here, you typically get 4 cuttings, but that 4th cutting, a lot of times, it's like, it's really economically worth running the equipment over that to get that, 3/4 ton or maybe ton of hay in that last cutting. So you can start thinking about it, it's less wheel traffic, less impact on the crowns of those plants. You save your harvest costs running that, the swather and the rakes and the balers and all of that. So up to maybe $80 an acre cost savings, like cutting out that last cutting. So you get improved persistence because of less wheel traffic, but I think you also get possibly improved persistence because you let that plant, the plant's going to be at its highest carbohydrate reserves at full bloom. Okay, so you let that go a little longer, you get a little higher carbohydrate reserves, you're going to have a little more vigorous type plant. So again, I think this needs to be proved out in field trials, but I think the potential exists anyway for improved persistence, longevity of those stands. And again, this greater flexibility, you may want to try to stay on a 28-day schedule, but if you get into those situations where you get the big rainstorm and you can't get in the field and you get things pushed out 7 to 10 days, you still be able to capture a higher quality product. Some other things that kind of come to my mind, this later harvesting, that's something I always talk with guys about, if they get delayed due to rain or something, the potential exists to remove those growing points. Once you get out there around 28 days, you get those new shoots that are starting to come down in the crown of that plant. You start pushing that out to 35 days or so. You have to be careful because if you remove that terminal growing point on those new shoots, it has to start all over again with another set of new shoots, so you can delay your regrowth. So I always tell guys, get down on your hands and knees, dig down in that crown a little bit, and see where those new shoots are. You may gain a lot by raising that cutter bar up a little bit, so you're not cutting off those growing points. This idea that, if you let it go to, 10th bloom, 20% bloom or more, could be beneficial for some of our pollinators. Big trouble with some of the bee populations right now, so this could be a positive benefit for the bees. Sustainability lodging has always been an issue or a concern, I guess, that people have when we talk about these low lignin alfalfas. To date, what little's been grown in the field doesn't seem to be a whole lot of reports of any incidents of increased lodging compared to conventional type varieties. So I think that, at least right now, with the varieties and what's out there, that's not a big concern. So getting your bottom line, a lot of this needs to be verified with feeding trials, but just running some of this through the milk programs. An increase in neutral detergent fiber digestibility of 1 percentage point can result in about a 2 to 3 percentage point increase in the RFQ value. That's going to translate to maybe 21 pounds more of milk per ton of hay. Again, some of the increased digestibilities has been showing around 10% higher fiber digestibility. So your RFQ, maybe increase 20 plus points. You can get a premium for that, so maybe $15, $20 plus a ton premium for that higher RFQ. So with that, I'll leave you with this thought for the day and try to answer any questions you might have.
Any questions for Joe? Joe, on lignin, does the quality of the alfalfa and the lower lignin, does RFB capture that? I mean, you talked about RFQ, but will that have any effect on the RFB number?
Probably not much. Because we saw, some of that little bit of data I put up, it showed that the the NDF, total NDF, didn't really change a whole lot. And so that's what goes, ADF and NDF is what goes into RFB. And the RFQ captures that digestibility. That's the big selling point for the RFQ, is it captures the digestibility of that NDF fraction. You're not going to capture that in RFB.
Any other questions for Joe?
I noticed you had one sheet you kind of passed by, talking about the NIR and the lignin numbers between grasses and alfalfa grasses and forages. If a lab were to use the wrong number, would that have any impact as far as the test?
So say that again?
Because I've had times where I've sampled hay or resampled people's hay, and I've seen lignin numbers that fall under a 5, which on hay that I would call marginal. I would think that was calculated wrong. Would that have any impact on RFB or the RFQ if they use the wrong NIR number?
No, it definitely could, I think.
Can I repeat the question, Joe, for?
You need me to repeat it, or you got it?
So you sampled some marginal type hays and this is the lignin number or which number?
I know really low lignin numbers.
Okay, so on alfalfa.
Yes.
Yeah, so, yeah, especially on alfalfa that's, fairly mature, let's say maybe kind of a large alfalfa. I would think that lignin number should be up around, 6.5, 7 anyway.
At least.
And if it's less than 5, yeah, I would start to question that number. And like I say, NIR, there's a lot of labs that have gone to that, and we use that a lot because we get the numbers back very quickly, and we go to these more complex equations like RFQ. That's about the only way to really get that back quickly. It's only as good as the equations that have gone in to predict that. So I think there needs to be a lot more done with looking at, especially with these new low lignins coming on the scene. I think there needs to be a lot more testing and verification being on our own machines, getting the true numbers out of there, correlating back to the wet chemistry values.
Do they use the same NIR calibration for grass and alfalfa? Or are they different?
They're different.
And corn silage just would be different.
Yeah, corn silage there's equations for corn silage, there's equations for grass, and there's equations for alfalfa.
What would they use for a grass alfalfa mix?
I think there's a Anwar, isn't it, for grass alfalfa, isn't it included in the grass equations? So.
It's not truly, but I have my own NIRS. I actually did a lot of wet chemistry and my own, and then I adjusted my machine and it works very nicely. Truly, there is no equation, never mind. But I myself did something on my NIRS.
Yeah. I think the database on the NIRs is getting larger all the time, and I think that I think it's in the grass equation. It includes grass alfalfa, that's the grass legumes. So there's in that database, it can pull from samples that have been run on grass alfalfa mixes.
Would the NIR calibrations for, say, for instance, Colorado hay versus Wisconsin hay, is there a difference?
I'm not a big expert on NIR. You find you've got a machine and you run a sample through it. Again, I think the possibility exists for that. I mean, you can have localized differences. But again, the database is becoming larger and more robust, I think. So it'll generally tell you if it's out of range on different samples. So you either have to retest them or run wet chemistry to verify, compare back to the numbers you're getting off of the machine.
There's been a discussion, say you have two different hay lots that have, say the same relative feed value number, say they're both 180, but maybe one milk's a little bit different than the other, maybe considerably better, considerably worse. And then particularly with the low lignin, is there something that the growers could do or the industry could do to encourage or a way to get that value back out of, get them away from relative feed value to maybe something different? Is there anything that we can do as a grower group or an industry to encourage that?
Well,
RFQ. Go to RFQ.
I mean, RFQ is where you need to go, and I think a lot of the labs now are giving you both values. when you send something to the lab, you'll come back with an RFD as well as an RFQ number. So we just gotta get people looking at the RFQ number. I mean, the whole idea of RFQ is they set it up so the numbers are, you can interpret the numbers the same way as you did the RFD number. I mean, you got this 1.23 constant and you divide by, so that puts those numbers on a similar type scale as the RFD number. It's just that they should be more accurate as far as, like, say, when it comes to milking, gain, and whatever. And then again, it's sort of this total track digestibility that we're talking about now. Further things.
Any other questions for Joe?
With the GMO, if you silence the gene that has to do with the lignin, is there any noticeable difference in the structural stability of the alfalfa?
Well, that's what they're saying right now, is all of the field trials, what few field trials have been done, and, Alfalfa has got some actual commercial fields in production this last year. I don't think they're seeing any.
No, the question was, have we seen any lodging differences between the low lignin and conventional varieties? And at this point, we haven't seen any more lodging concerns than just conventional alfalfa. Stands up just as good.
And that's I guess the beauty of the alfalfa, it has 6-7% lignin in it, compared to, like a grass that has 3%, so there's probably some lignin there that we can get rid of without really influencing the standability of that plant. And so far, it seems to camp out.
Anybody else?
So Joe, what do you think about low lignin alfalfa's future? Really, this is a good thing, all we should consider?
As the future of it,
Yeah.
I mean, I think once we get just a little more data in, I think it's gonna, I mean, why wouldn't you want to go to it, I guess? I mean, especially if you can spread that harvest window out. Like I say, even if you want to try to cut on a 28-day spread and keep on that, you're going to capture higher quality, but if you do get into that rainy period and you get pushed out, a week or 10 days, you're going to still sacrifice some quality, but, it's the same quality you would have gotten if you had been the traditional, conventional variety at 28 days. So, yeah, I don't see many big drawbacks to it.
There's oftentimes we get the question, as with sometimes new technology, you experience a yield drag. And with the, at least with the Higest, last year, we didn't experience that at all. It's a high yielding elite type genetics, which have been selected for low lignin. We sold Higest both in fall dormancy 3 and fall dormancy 6, and for this coming year we have a fall dormancy 9 and a 10 for the southern folks. But those people that use that product extremely happy with it, and now they're coming back and buying more. But each one of those people that the growers that planted that, we gave them a coupon for a free forage test kit at Rock River Labs. And so we were able to monitor that quality under all kinds of conditions clear across the United States. And that information started to come back was extremely favorable. So we're pretty excited about it.
Well, I think, Alpharex going through the traditional breeding approach, I wouldn't expect to see a big yield drag on that one for sure.
Yeah.
The GMO and silencing genes have probably greater potential there, but I don't think we've seen that on
I know export of hay has been a real big market for a lot of folks, and particularly on the West Coast. And more and more of that hay is becoming contaminated with the Roundup Ready gene, and so they're coming further east to try to pick up some hay that hasn't been cross-pollinated or contaminated one way or another. But that export market is a big deal, and that's where the non-transgenic Higest products have a real good fit too.
So question to both of you, as an extension specialist at Wyoming, it's really like a very hot cake now. Everybody calling me, could you please tell me what variety should I go? I heard that we can increase meal production 2-3% all year. So I cannot really give them straight recommendation unless we see something truly. But many has really interested, and it looks like a very good market in the near future. But my only concern is, you know, when you go, it's a non-transgenic, that's a good thing. But the other thing is when you reduce the lignin in the near future, how tolerant that will be with the pest, and how losing tolerant that will be. So that's my only concern as a scientific standpoint. So what would be your answer on that in the longer term?
We have to wait and see. And that's why I say, this is so new, there's a lot of potential, but we don't have all of the answers. Like I say, the pest issue might be one, because lignin does provide some pest resistance to the plants. So, I think they're trying to, through the breeding process, they're trying to make sure that these genes are in the elite lines that have pest resistance. Is that truly going to carry over?
One thing that we've seen this past year, as you all know, there's hay prices have taken a pretty steep decline throughout the country, particularly in the West. And there's a lot of hay sitting around, but one thing for sure, there's not a lot of really good hay sitting around. That's always the first hay to go. So a lot of guys are turning to products like Higest and the Harv Extra just to get that quality, get as good a quality as they can possibly get, and be able to market that for a top dollar. Well, thanks, Joe.
Yeah.
Appreciate it.